Hi everybody, so this is going to be a couple of video tutorial walking through the actual project called the Gatenbein Winery. We're going to do this in 3 different steps or 3 different paragraphs, and then I'll have a 4th video that introduces assignment number 2 as well, so you can watch all those. If you want to skip right ahead and watch the assignment 2 video, you can do that just so you have a little bit of understanding about what's going on, or you can wait until we finish this exercise and then watch that as the 4th and final video. Also, I want to apologize for not being there in person today. Unfortunately, I'm having some kind of family medical issues and just need to be here and around for my family today. So I figured instead of doing the video tutorials like I mentioned after spring break, might as well go ahead and jump in and do one right away. Again, this way you can kind of take it at your own pace and work your way through. So to get us started, we're going to refresh you with the Gatenbein Winery project, and this is all available on Carmen for you. So if you haven't yet, you can go to the Carmen website and download all these files. These are the same files I put up last week. If you just go to the files on the left here, Gatenbein Winery, the 5 in the middle here are just images of the actual project itself. You're going to need to download the Rhino file, which is assignment. It's labeled as assignment 4 here, but it's assignment 4 within the image sampling stuff. Gatenbeinwinery.3dm. And then you're also going to want to download this right here, which is the sphere. We're going to use this as the image. The Gatenbein Winery uses a series of spheres, but we'll talk about that in a moment. So go ahead and have those files downloaded, and we can kind of take it from there. So just as a refresher, some of the imagery from the actual Gatenbein Winery is here. It is. They're broken up into these individual panels, and those panels are made up of a series of stacked and rotated bricks to create this image of the actual winery. There it is from a slightly different angle. The interior view of it, and another angle from the interior view. And this is kind of the image of how it was generated. So here what we have is the kind of a progression. This was an animation of a series of these spheres of different sizes, a small, medium, and large. And it looks like being dropped into this kind of cage, which represents the actual structure of the building. So if you see in my Rhino file, I've kind of mimicked that just with this real generic little representation of the structure for that paneling system. And then at the end of the day, that's how we get the image, which constitutes this final collection, which is how they use it. Now what we're going to actually use is this sphere image. I believe it's going to jump here next. We're just going to use this to map it, and the idea here is we could essentially use any image we want, convert it to a grayscale value, and be able to use that to control it. So it doesn't have to be the grapes at all. We can swap in and out our own image and make it work there. Now we are going to stretch it because, as you can see, the actual structure is much more rectangular, where the image that we have is much more square, circular sphere inside of a square image. So we are going to stretch it, but that's okay. It's not going to cause any issues with the actual definition itself. Let's go ahead and get started. This is the file you should get when you download that 3DM file from the Carmen site. And we're going to go ahead and focus only on one facade, and one facade being these kind of 6 panels. I'm focusing on the one that's on the y-axis here, or excuse me, the x-axis here. And to start with, I'm going to focus on this lower left panel. We're only going to do one panel, but it's expected that you go ahead and reproduce this for all the panels. All you're going to do is basically copy paste the definition and reassign new control points for it. So what we want to do is in the corners of them, you'll see these individual points. These represent the corner points of a surface. So what we're going to do is we're going to use a 4-point surface, generate a surface within here. We're going to subdivide it to create the bricks. In this case, we're going to do a running bond pattern within there. We're going to do it a slightly different way, but very, very, very similar to what we've done in class to create that running bond pattern. Then what we're going to do is we're going to use the image sampler, measure the grayscale value, and use that as the brick rotation within there. And again, we're going to only sample the lower 6th region of the image so that at the end of the day the whole image stretches. We're not going to just map one sphere inside this one panel. We're going to break it up so that the sphere maps across this entire facade and each panel gets a portion of that overall image, and we'll work our way through that. Alright, to get started, let's go ahead and work with a new Grasshopper script. I'm going to go ahead and just kind of dock this over here on the right hand side for us. And what we need to do is we need to reference in these 4 control points, because those 4 control points are going to be our 4-point surface. To do that, let's go underneath our parameters tab, geometry, and let's just go ahead and drop in 4 of these, and we're going to label them points 1 through 4. I'm going to just go ahead and quickly evenly distribute those, relabel them right away. So point 0, point 1, point 2, and point 3. And this is your opportunity to go ahead and pause whenever you need time. I'm not going to pause. I'm going to just kind of keep moving on. But when you need a moment, go ahead and pause, write some notes, do whatever you need to kind of work your way through it. Some of this stuff I'm going to assume you already know, which is things like how to go ahead and add control points. I say that, and I did it wrong, obviously, the first time. So let's make sure nothing's selected. Right-click, set 1, and go ahead and pick the one in the upper left. Then I'm going to go to the lower left, then lower right, and then upper right. It is important that you do it in some sort of an order, whether it's clockwise or counterclockwise, just to make sure that your surface does not kind of twist, turn on itself, things along that lines. So, okay. And I'm going to set the last one for my upper right corner. You might as well do it the same exact way so that we don't have any issues with orientation or the way that the original geometry was created. All right, as I mentioned, we're going to do a 4-point surface from here. So we're going to have a surface tab. We're going to go underneath our freeform and 4-point surface in the upper left. Going to have to wire those in one at a time, A, B, C, and D input. Notice the interesting thing about 4-point surface is that you really only need 3 points to generate a surface. So when you start wiring the first 3, you actually get a surface. If I was happy with this and I only wanted that kind of triangular surface, I could use this right away. It's perfectly fine. But because I do have 4 points and I want to make a rectangle, not a triangle, I'm going to go ahead and wire in that 4th surface or that 4th point for us right away. So, okay, there we go. So now if you remember, the first thing what we did when we created the Church of the Christ the Worker was we created that bounding box around it and extracted the bottom edge. Okay, we don't need to create a bounding box because we could essentially just extract this bottom edge as it is. The reason we did the bounding box around the Church of Christ the Worker was because it undulated. Let's go ahead and just extract that very bottom edge. We could go do this a couple ways. Like I said, we could do the bounding box, deconstruct brep. Gives us our faces, our edges, our vertices. We could be interested in the edge condition. So we'll go to sets, list item, and we want to pull out whatever one of these bottom edges is. Okay, which one of the bottom edges. The 0 one, it's hard to see, but you'll see a vertical green line right there. That's not going to work. So I'm going to put a panel tool in. I'm going to say I want to extract the 1 edge, and let's see which one that is. Because I constructed this in the order that I did, let's go ahead and just verify. There it is, that bottom edge. Because this was my first point, second point, this sets up the 0 edge. Then this is the second to third point, that sets up the 1 edge, so on and so on. So it's kind of an easy way, logically, if you constructed your surface the same exact way, we could do that. The other option is, because it is just a surface, we could go under our surface analysis. We could also use things like brep edges or brep wireframe to also get those wireframe edges. All I did was I created we just did deconstruct the brep because that gives me faces, edges, and vertices. It just gives us more information to be able to use potentially in the future. Now I have my bottom edge from there, and now I want to go ahead and I want to create individual section cuts from this. I want to divide this up essentially. So I'm going to go underneath our curve, division, and I'm going to divide curve. And this takes a curve, it divides by a number of times. I actually don't know the number of times. I know how wide I want to space those because those are based off of the brick widths. I don't know the number, so that might not be the best one. What I want to go, let's go back and let's go to divide. This time we want to do divide by distance because we know the distance between each point. Perfect. The curve I want to divide is that bottom edge curve. And the distance is going to be the brick, in this case we're doing the brick width. Okay. And then we're going to divide that up, and then we'll create the individual nodes, and then create the brick heights from there. Okay. So to do that, let's go ahead and drop in our panel tools with all that information. We're going to do a brick width, and this is going to be 8 units. Technically, we're going to say 7.75. We're going to have an 1/8 inch material or mortar thickness in there. Okay. So I'm going to relabel this as brick width. We're going to label it as 7.75, and we're going to do mortar thickness within there as well. So what I'm going to do is I'm going to do brick width. Now I'm going to do brick height. and we're going to do brick depth. Okay. The brick height is going to be 3.75, and the brick depth is going to be 3.75 as well. And the last thing we need is a mortar thickness. And that's going to be 1/4 inch. Okay, and there we go. So there are individual brick dimensions as well as our mortar thickness. Now we want to divide the horizontal by the brick width plus the mortar thickness. Okay, so what I'm going to do is I'm just going to pull that down so we can see these three together real easily. I'm going to do an addition. Again, go under math, operators, and addition. I'm going to add the brick width together and the mortar thickness. That's going to say every 8 units. Go ahead and divide out that curve. And there we go. We've divided that horizontal curve every 8 units. Okay. Now what I want to do is I want to create vertical cutting planes on there. So at this location, I want a plane that would cut through my surface. My surface is on the XZ axis, so I need a plane that is oriented on the YZ axis to orient that, to cut that. So let's go underneath our vector, plane, and we want a YZ plane. We're going to locate those planes at all those nodes, all those points, and you'll see my planes run perpendicular or counter to my actual surface. Great. Now what I want to do is take a the brep object and intersect that with these planes. So we're going to go to intersect. Because we're dealing with one set of things that are planes, we're going to go underneath our mathematical and brep in planes. The brep I want to intersect is the 4-point surface right here. Let's go ahead and just drag this whole thing up a little bit so that the wires don't get, so that the wires don't get too confusing. This is the brep I want to intersect. So let's go ahead and wire that into the B input of the brep. And the planes I want to use are going to be those planes right there. There. I'm going to turn off some of this old information. And now I have vertical lines within here. Now those vertical lines, I want to go ahead and take those and I want to create the horizontal brick locations. Okay. To do that, we're going to go ahead and add the brick height and the mortar thickness. The same idea. So I'm going to Control C, Control V to add, copy the add component, the brick height this time, plus the mortar thickness. There we go. Okay. Now what we want to do is we want to take that and divide these curves by that same information. So I'm going to copy paste my divide curve, run my section curves into there, and the distance I want to divide by is this new addition I ran in there. So there we go. And the results, turn that back on and make it visible, are all these node locations. Perfect. Now that's really great for a stacked bond condition. Let me just organize this real quick. So what we want to do is this is all about creating the surface. So I'm going to group that. These are all of my variables. So I'm going to group those. This is all about extracting that bottom edge. Right click, group that. Okay. We have a simple kind of addition operations. So we can group that. This is all about creating the sections. So I'm going to group that. And then this last one is all about creating those individual nodes, those individual points. Perfect. Okay, so like I said, everything looks really good here, except for a couple quick little things, or one in particular. This works really well, except for the fact that this is creating our stack bond, and we want to do a running bond. So we know to do a running bond, what we have to do is create twice as many points in the horizontal condition, and then eliminate every other one. We're going to save the elimination for the next step, but let's go ahead and create twice as many. All we have to do is take our divide distance in the horizontal. So here's all the points that create our divide distance. And we want to divide by twice as many, okay? So to do that, we want to half the divide distance. So instead of dividing every 8 units, we want to divide every 4 units, okay? We can do a simple math and division and just say take this, divide by 2, and then that becomes my new distance. Or better yet, I can embed it into the input. So I can right-click, expression, x divided by 2. And that creates twice as many nodes. There we go. It creates twice as many nodes, and it creates twice as many horizontal brick locations for us to be able to eliminate a little bit later. There we are. So there's the first kind of step in here. I'm going to turn off everything except for that very last component. So you just see a series of points floating in space. Now we will also have issues where bricks overhang or aren't quite located. We can shift those. That will solve in another episode, if you will. But for now, we've got our individual panels located within here. Now what you want to do is go ahead and drop in a panel tool and write what our kind of steps are. So let's go in here, drop in this panel tool. I'm going to go ahead and stretch this. Whoop. I'm going to write a little note on here that this is Gatenbein Winery. This is step 0. And in here, I'm going to write what our overall goal was. Okay, and our overall goal, create points for brick locations in within panels. Okay, and kind of our steps here, we import the 4 control points. From Rhino. Create a surface from these control points. Extract bottom edge. And divide the wall height by the brick height. Intersect the panel surface or the 4-point surface with the, in this case they were YZ planes, and then sorry, one quick correction, we want to divide the wall width by the brick width, and then we divide the wall height by the brick height, and divide wall height by brick height. And you could say that this is plus mortar, if you want to do that. And then lastly is to double our horizontal points for a running bond. There we go. So that's kind of your first step within there. Now don't forget, you're going to want to go through here and annotate each of these individual groups, but we'll go ahead and start the next paragraph with the next section, and that's all about doing the whole cull and eliminate every other point. That should be a repeat for us, but nonetheless we'll do it as a group together. All right, see you then.